Well, hello again, everybody. We're going to be looking at homework 2.3, acceleration, and this will be number 6 that we'll be working on right now. Number 6. So we have an infamous train question right here. Of course, it's not the usual train question that people think about when they think of a train leaving Chicago at 2 a.m. and then a train leaving Philadelphia. Not like that, but it is still a train accelerating, and we need to find out what speed it will, or what velocity it will reach after a certain amount of time. So we have a train accelerating away from a station. So we can assume that if it was at a station, station is normally where trains stop. We can conclude that its initial velocity is 0 meters per second. And in the first instance, it reaches a speed or velocity, VF, we'll call it 1, of 4.7 meters per second. And the time 1 is 5 seconds, 5.0 seconds. So we need to find out, in a second it's going to ask us what is the velocity at an additional 6 seconds. So 6 seconds down the road from here, so 5 seconds plus 6 seconds, so at t, our t2 is 5 plus 6 equals 11 seconds. Question is, what is our velocity? Velocity final 2 is, we don't know that yet. And you would think that you would somehow need to find out your acceleration in order to calculate the velocity at 11 seconds, but that's not true. All we need to know about our acceleration is what we were told, and that is the acceleration is constant. That is, the acceleration, I'll write it up top here, acceleration 1, whatever the value is the same value as acceleration 2. If we recall that any acceleration is the change in velocity, that is delta v over delta t, which is the same as final velocity minus initial velocity over delta t, then that means that we can set this 1 equal to that 2. What I mean is this. If A1 is equal to A2, then VF1 minus VI1 over delta T1 equals, or is the same thing since the accelerations are the same, VF2 minus VI2 over delta T2. Well, we know almost all this. We know our final initial velocity. We know our absolute initial velocity. That's the same thing in both scenarios. In both instances, you start from 0. And we have our time 1, and we have our time 2. All we really need to find, to solve for, is VF2. What is our velocity, our final velocity, at the second time increment, at 11 seconds? Well, we can solve for that. If we bring our delta T2 up, so we multiply both sides by delta T2, that would come to the numerator over here. Delta T2 times all this, VF1 minus VI1 over delta T1. And then if we add VI2 to both sides, this goes away, and we take it over there. So plus VI2, that allows us to solve for VF2. So delta T2, what is that? That is 11.0 seconds times VF1, 4.7 meters per second, minus 0 meters per second. All that over our T1, which is 5 seconds, plus VI2, that is both VIs, that is both initial velocities are the same, which is 0 meters per second, or plus 0, gives us our final answer. And our final answer is 10.3 meters per second. 10.3 meters per second. It's our VF2. Sorry, I ran out of space right there. 10.3 meters per second, VF2.